Children, there are different types of force. Examples of force we have already studied. Driving, bending, lifting. If I want to lift this box, I have to apply force. If I want to keep it again, then also I have to apply force. For moving from one place to another, I have to apply force. While playing football, if I want to kick the football, I have to apply the force by our foot. Then, while playing cricket, while plowing the field, for so many things, for everything, we have to apply force. Now, we will study the different types of force one by one. There are 6 types of force here. For that, I will give you one clue. माँ मैंने गीता में फूल एक रखा. माँ मैंने गीता में फूल एक रखा. In that, 6 types will be covered, summarized in single sentence. माँ muscular force, mechanical force. माँ मैंने गीता में फूल एक रखा. Muscular force, mechanical force, gravitational force, magnetic force, frictional force, electrostatic force. Let us study the different types of force one by one. First one is muscular force. In Marathi it is called Snayu Bal. The definition of muscular force is force applied with the help of muscles is called muscular force. See, with the help of muscles. The examples are weightlifting, then playing football, playing cricket, bullock cart, driving, bending, pushing, pulling. All these are the examples of muscular force. Then mechanical force, yantrik bal. Force applied with the help of machines is called mechanical force. It is applied with the help of machines. For example, mixer, grinder, then washing machine, sewing machine, electric pump, fan. All these are the examples of mechanical force. Then gravitational force. Force applied by earth to pull object towards itself is called gravitational force. Gravitational force we have already studied. It is the gravitational force, this concept is put forth by the scientist, great scientist Sir Isaac Newton, and he explained that there is a force applied by earth and this force pulls the object towards this earth, towards itself, and this force is called gravitational force, Gurutvakarshan Bal, Gurutviya Bal. Falling down a ball, if I throw this pen upwards, at that time it will go upwards to some extent, but after that it comes downwards. Why does this happen? Only because of gravitational force. Because the earth is pulling, it acts like a giant magnet and it pulls the things towards itself. Then dropping a stone. Dropping a stone is also an example of gravitational force. Force between sun, planets and satellite. This solar system, it is also intact because of this force. Gravitational force. The gravitational force acting on an object is called the weight of that object. And while doing the weight, calculating the weight of the object, we use spring balance. See, This is a spring balance. It is having spring inside it, and now I am trying to weigh this object, this mobile pouch. For that, what I have to do? I have to hang the pouch on the hook of the spring balance. And now what happens? The gravitational force, it is pulling this spring balance towards itself. But the spring in this spring balance, it is pulling that object upwards. And there is tension, pressure, there is tension created on this spring, and there is gravitational force that is acting on it. Then what happens when these two become equal, this tension in the spring and the gravitational force acting on it? This spring, it is pulling upwards, and this gravitational force, it is pulling downwards. It comes to rest, this spring, it comes to rest when these two become equal. These two forces, they become equal. And then we observe the scale on this spring balance, and this scale shows the gravitational force that is acting on an object. See, it shows that it is near about 250 gram. 250 gram. See, it is here, and this means that the weight of this pouch with the mobile is near about 250 gram. So, we have studied that gravitational force acting on an object is called weight. Now, magnetic force. We know that there is attraction between the opposite poles of the magnet, and there is repulsion between the like poles. And based on that, we have seen so many things, and magnetic compass, it is an example of this. See, it is used by so many people, and especially the sailors in the sea. They use this magnetic compass so that they can understand the directions. It always remains north-south. It remains constant in the north-south direction. See, here you can see that there are 8 directions graved on it. And these markings, if we move this magnetic compass and make it stable at that time, what happens? After some time, it will become stable, and it will become stable in only north-south direction. Okay? In this way, this north-south direction shows that it is having magnet, and this magnetic compass is very useful for specifying, for deciding the directions. Then magnetic belt. If the mixture of magnetic and non-magnetic substances is taken, and we have to separate the magnetic substances, then those are passed through that magnetic belt. This magnetic belt attracts the iron, nickel and cobalt things, and they get stuck to the magnetic belt, and non-magnetic things, they are pushed aside. Then frictional force. The force created by friction is called frictional force. I have told you that sometimes we require the increase in the friction, whereas sometimes we require the decrease in the friction. That means friction should be reduced. While playing carom, friction should be reduced because this striker should go smoothly. But for applying brakes, there should be friction. We know that there are rough surfaces on the ramp of the railway station. Why? And also if you observe the new tires, they are having grooves on it, and after using them for so many years or days, what happens, those grooves, they become flat, and then the skidding or the falling of that vehicle occurs. Why? Because the friction is reduced. In case of tires, in case of ramp of the um, railway station, we require the friction. And if this surface is made rough, at that time what happens, the friction is increased, and because of that there is more friction between our feet of the person and the ramp of that railway station. If it is rough, there will be more friction, and because of more friction there will be less chances of skidding or falling down. That's why the ramp on the railway surface, they are also rough. And electrostatic force that we have seen, it is temporary one, it is not the permanent one. And this electrostatic force, it goes after, it disappears after some fractions. In this way, we have studied the different types of force, and there is one another concept, that is combined forces. Variety of forces are there, and they are acting on the object. At that time, it is called combined force. You must have seen roller coaster, and this roller coaster, it has so many types of forces. They are acting combinedly, and that's why they are called combined forces. Sometimes frictional force is required, whereas sometimes frictional force is not required. It depends upon the situation where it is used. For example, carom, applying brakes. While playing carom, the striker is hit with the help of fingers, and then what happens, if we sprinkle talcum powder on that carom board, it reduces the friction between the surface of the striker and the surface of the carom board, and because of that, what happens, the friction is reduced and playing becomes very easier. And so we sprinkle talcum powder while playing carom. Then applying brakes, we generally see that we oil our bicycles regularly. Why? Because there is wear and tear of the parts of the bicycle or machines, they are also oiled frequently. Why? Because there is wear and tear of the parts due to the frequent use. And after that, what happens? This oiling reduces the friction between these parts of the machine or parts of the bicycle. And if the friction is reduced, it will go smoothly. And that's why we apply oil, or we oil the bicycles, or we oil the machines regularly. Then applying brakes, it requires friction. Then grinding stone, in olden days mother used to grind the flour, wheat, jawar, bajra with the help of grinding stone, jate. In that also there is friction between the two surfaces, and between these two surfaces, those grains, they were grind. Then electrostatic force, we have studied the static electricity, and force exerted by electrically charged materials is called electrostatic force. Force is exerted by electrically charged materials. For example, if I take the pieces of paper, and then if I do the friction of my hair and this pen, and if I take it near the small pieces of paper, you have seen that pieces of paper get attracted towards the comb or pen or any plastic thing, ruler, and because of that there is static electricity, and this static electricity produced on rubber, plastic, ebonite is an example of electrostatic force. This is the force exerted by electrically charged materials. So, we have studied the different examples, the definitions, as well as the importance of all these types of forces. You must have understood all these things, and you have to revise all these things frequently by watching the video so that they will be remembered and they will be captured in your memory box forever. Thank you.